in this clip, we're going to be studying compact bone anatomy. What this means is we're going to be looking at a typical bone, but we're going to be zooming in on the microscopic structure of the compact bone, the really dense, tight-knit bone material that makes up your bones. And so here what we're going to do is let's take a little section out of a bone, and we're going to zoom in to understand how this compact bone is arranged at the microscopic level. First, what you're going to see is that you have compact bone, or the long bone, surrounded by the periosteum. And we looked at the periosteum in the long bone anatomy video. And so this is the layer that is going to surround the bone. It's going to provide it some protection, anchoring of the tendons and ligaments, but also contains some bone cells that are important for the maintenance of bone tissue or the production of bone tissue. But then if we go further inwards into the bone, what is this bone going to be made up of? And so the first thing that you're going to notice is that you have what we call organized structures, a circle or a canal that spans the length of the bone, and this long canal is going to be surrounded by circular structures. So let's go ahead and break down what we are looking at. So this canal, we are going to call this the central canal. But the central canal itself is surrounded by ring-like structures very similar to the rings of the tree. And these structures are what we call lamella. E makes it plural, and lamella with an A is a singular term. And so because these lamella encircle or surround the central canal, we call those concentric lamellas. Or lamella, concentric lamella. And so one central canal with the concentric lamella around it, this makes up what we call an osteon, also known as a Haversian system. So as you can see, compact bone is made up of repeating osteons or repeating Haversian systems all throughout this compact bone anatomy. So what's the significance of this? Well, as you can see, inside the central canal we have blood vessels, arteries, veins. We also have those yellow nerves. And so our bone is vascular. It contains a lot of nerves, so it's an innervated structure as well. And so all of these are running inside the central canals. What you'll also see is that you have these little channels running perpendicular or sometimes diagonal to the central canals, and these are for the purpose of communication between the different osteons, and so we call those the perforating channels or perforating canals. So now, let's go ahead and zoom in on a single osteon. So let's carry this over and let's create a bigger diagram here to show the microscopic anatomy of a single osteon or Haversian system. So let's go ahead and draw our central canal as the circle in the middle, and then let's go ahead and draw our concentric lamella, circular structures of bone matrix surrounding the central canal that are going to give it some rigidity, support, and structure. So this is going to be your central canal. Inside of it, we're going to find our veins, our arteries, as well as our nerves. And so what we went ahead and labeled these, and these are going to be our lamella. So now what you don't see in this picture yet are little chambers that are going to be found inside these concentric lamella. And these chambers are what we call lacuna. Again, lacuna with an A for singular or with an E at the end for plural. And these lacuna are little chambers, and they're going to house your mature bone cells that we call osteocytes. So inside these lacuna, you're going to have cells that are your bone cells, mature bone cells that we call osteocytes. And they are really important because they help maintain the bone matrix. They help also with repair. And then finally, attaching or helping the communication of these osteocytes in the lacuna to other chambers and other osteocytes in different chambers, we have small channels linking the lacuna to one another, and these channels are called canaliculi, or canaliculus for plural. So small chambers to allow communication between the different lacuna and the different osteocytes from one lamella to another.